So I call this KH2, which is exactly what it is, but it has a big name too, right? And then I call this KHO. So we use, in this case, vitamin K plus carbon dioxide in this gamma carboxylase enzyme. So in order to do what we're talking about, we need vitamin K. That's the take home. All right. Vitamin K serves as a cofactor for the enzymatic reaction involved in converting blue to GLA. This process occurs in the lumen of the rough ER, right? Again, I'm going to draw a picture in a minute. So, okay. So, how does this work? Proteins are recruited to the rough endoplasmic reticulum due to the presence of a signaling peptide. The signaling peptide is removed in the lumen of the endoplasmic reticulum. The N-terminal end, the propeptide end, is exposed and recognized by gamma carboxylase. To accomplish gamma carboxylation of blue to GLA, vitamin KH2, which is vitamin K hydroquinone, is required. Proteins migrate to the Golgi where they undergo glycosylations. There are 3 types of modification. Proteins are released from the propeptide in the Golgi. Zymogens are released into the bloodstream, waiting to be activated by the clotting cascade. Okay, so this process should look pretty familiar from before. There's nothing distinct I want you to know about this. I'm not going to make you memorize each step in this. But if I'm telling you that it's, that you've got a pre-active thing and it's going to interact with the gamma carboxylase enzyme, I want you to know that that means it's converting blue to GLA. All right, that's what's happening. And then once that blue to GLA gets converted, they go out into the universe of the bloodstream and they're ready to be further activated. So let's highlight that. Let's see, suppose, there we go. I'm going to highlight gamma carboxylase and Amish, yes. And once, remember, if you go back up here, once this happens, right? If you convert glutamic acid residues to gamma carboxyglutamic acids within the proteins, you allow for calcium binding. That is activity. You become an activated protein. So gamma carboxylase does this using vitamin K. Is that good? All right, so, and then remember to be active in their little picture, 10 flies by and attaches to 7A or whatever and becomes 10A. That's further activation. This is just when you release this protein, the glutamic acids have been changed to the gamma carboxyglutamic acid residues. Remember, because if you look in that picture, calcium was involved in that. Right? Those big white molecules were calcium, so you needed calcium there too. What did those do? They bind to calcium. So let me put that in a little